Hello friends, in today's class we are going to talk about different scheduling policies such as first come first serve SGF and different optimization criteria. Welcome here, and we are talking about CPU scheduler, and the CPU scheduler is a process is the process of the decision of which process will be allocated to CPU. Okay, so the decision of which process is allocated CPU, that will be taken by the CPU scheduler. Now this process involves many optimization criteria, such that we want the CPU to be maximum utilized, right? Maximum utilization we want. We also want that there should be a minimum waiting time. So like that, there can be different criterias can be there of or different for different policies. So here goals of the CPU I'll say scheduler is this is the goal they want to achieve, that they want CPU utilization, and the simple definition is how busy the CPU is. Throughput. Okay, now utilization and throughput is something like, here I can say that only 90% of the time CPU was busy and 10% of the time it was idle. Throughput is the, whenever we say use the term throughput, is the how many jobs completed in unit time, right? So the number of jobs completed, right? So that is your throughput. Turnaround time. So turnaround time is between the two time that the submitting the job and the termination of the job. So when I'm assigning a job, submission of job means we assign the job, or it is in the present in this ready queue, and the amount of the time it will take to terminate. Response time, to get a response from a stimulus. Okay, so how long does it take to get a response? And this term we'll see in the detail. Maybe you will start getting the response, we can say that, from first time when CPU is allocated, right? So that can be one criteria, that how long and on average does it take to get a response from a stimulus. Missed deadline, where if we are having restricted that this process should be run within that deadline, have we missed the deadline? Okay, so these are the few criterias and some few goals that it want to achieve, the scheduler want to achieve. You have few related options with the scheduler, that you have a priorities, means a few jobs may have few jobs, or the process may have a higher priority compared to another one. So the process which is the jobs related with the response, okay, means GUI. So response is very critical to this scheduler, and definitely they will have a higher priority. And they can also can use to determine that who will run next. And there is a concept of dynamic and static scheduling, and dynamically alter the priorities, the task while they are running in the system, where static is typically assign a fixed priority to the job initially started. So we can have a dynamic, means the system started with, let's say, with the priority 1, and that I will call it as a highest priority. Lesser the number, higher the priority, higher priority. And suppose the number started with 10, and over the period of the time, that because we want to avoid that it should pay the attention over the period of the time, it reaches to 2, and that is your dynamically we are altering the priority. But in static, 10 will remain as same. And this is another criteria, preemptive and non-preemptive, that Do we have the algorithm that forces, okay, the forces a process to quit, to relinquish the, let's say, CPU? So can we preempt it? And preemption can occur because of what? Because of that there can be many reasons of the preemption. So that can, is it possible, right? So preemption and non-preemptive, that's it, that criteria or options are there. So there can be arrival time, that the submission time is there. So some time, and that notation I can say here that AT, arrival time, is there. Waiting time is WT, that before it has been allocated to CPU. Burst time is the service time. Okay, the service time means the amount of time CPU is allocated. Completion time. Okay, completion time is something in which job will be completed. Turnaround time. So this completion time and the arrival time, okay, that is your turnaround time, and this is one of the very important aspect in gate examination. Okay, completion time is the time when process completed. And completion time minus arrival time is your turnaround. Response time, time of submission of the process to obtain the first result of the response. Okay, response time is that. Okay, so now turnaround time is what we have already seen, that a completion time minus your arrival time is your turnaround time. And if you just want to get the average, so just do this computation for each process, add it up, summation, and then finally 1 over n. Waiting time. Okay, waiting time is what during all the time it is present in the CPU, it may or may not be busy, right? May or may not be allocated to CPU, correct? So rest of the time, what? Rest of the time it will be waiting. So completion time, turnaround time minus burst time, that is, this is the allocation of the CPU time, right? Allocated to CPU burst time. But rest of the time it is been waiting. And turnaround time is what? Completion time minus arrival time. So completion time minus arrival time minus burst time is your waiting time. And now we can say that average waiting time, and that will be 1 over n for all the processes. Completion time minus arrival time minus burst time, right? Completion time minus arrival time minus burst time. Schedule length will be the maximum completion time minus minimum arrival time. And throughput is L by n. So L is your the complete time, and the number of process that you're completing is n. So these are the thing that we want to scrutinize the behavior or the performance of the scheduling algorithm. Deadline is the completion time minus di, and if it is less than 0, then suppose the deadline is 4 and you're completing at 3, so you are under the deadline, right? Ci minus di is less than 0, then under the deadline. Ci minus di is 0, then on deadline. And here you have missed all the deadlines here. This. You have we were going to talk about different scheduling policies in that. We'll start with simple one, that FCFS, first come first serve, and then we'll see the non-preemptive version of shortest job first. We'll see the preemptive version of shortest job first, and that is also called as shortest remaining time first scheduling policy. We'll see the priority scheduling, we'll see the round robin scheduling, we'll see the multi-level queue scheduling, and finally we'll see the multi-level feedback scheduling. Okay, so these are the different policies that we are going to talk about in the next lecture. So this is all for this section, and I think the main part is here, and this part and this part, this process time, the different times, and this one, these are the question asked in the examination, and whatever examination you are preparing for, even if it is GATE or any other examination. So these are the some computation part is here in scheduling policies. Okay, so we are done with this. In the next section we'll start with this different policies, and we'll start with FCFS, first come first serve, right? So that's all for here. Thank you.